All right, Preston, here's some basics on moles, grams, molarity. So, one of the things you got to understand in chemistry is we often measure things in grams, but we're often concerned with how many we're dealing with. So, grams is like how much, but moles in atoms and molecules are how many you're dealing with. That's especially important when you start talking about chemical reactions and you got to abide by mass conservation and some other things. So basically, grams is how much, moles is how many, and atoms and molecules is also how many. So you got to be able to convert from one thing to another. So for example, if we're going from grams to moles, okay, how do we go from grams to moles? So if we had, uh, you know, I don't know, like 1 gram of sodium, how do I know how many moles that is? I would have to multiply by a certain factor, which would basically be 1 mole is how many grams. And for sodium, if you go to your periodic table, you'll find that the molecular mass is about 23. So 1 mole of sodium is about 23 grams. So I could go from grams to moles by basically dividing by my molecular mass. 23 grams of sodium in 1 mole. And that would give me a mole value. If I wanted to go from moles to atoms to molecules, this is where you would basically multiply by Avogadro's number. So 6.022 times 10 to the 23rd per 1 mole. So there's 1 mole of anything is always exactly this many atoms or molecules, depending on whether you're dealing with obviously an element or a compound. Okay, so if you had I don't know, like 2 moles of whatever, you can multiply by Avogadro's number. If you got to go the other way, if you need to figure out, well, how many moles do I have based on the number of atoms or molecules, you divide by Avogadro's number. And if you want to go from moles to grams, you multiply by your molecular mass instead of dividing it. So if you're going that way, you divide by your molecular mass. If you're going the other way, if you're going moles to grams, it would be, let's say you had, let's say you had 2 moles and you want to go to grams. Well, 1 mole of sodium is 23 grams, right? So if I did that math, we're dealing with what, 46 grams, right? If I had 2 moles, it'd be 46 grams. So again, how much, how many, how many? If we're going grams to moles, you're going to divide by your molecular mass. If you're going moles to grams, you're going to multiply by your molecular mass. If you're going moles to atoms or moles to molecules, you're going to multiply by Avogadro's number. If you're going atoms to molecules, 2 moles, you're going to divide by Avogadro's number. Okay, so this factor is constant, but your molecular masses vary. It really just depends on what you're dealing with. So let's take a look at a couple of these problems here. I guess before we get into that, another thing we should mention is just in general, if you want to make a 1 molar solution of anything, you're basically going to take the molecular mass, and then you're going to make sure you add enough water so you have 1 liter total. Okay, so if I was making a 1 molar solution of sodium chloride, I would say, okay, sodium has a molecular mass of 23, chlorine has a molecular mass of 35. So sodium chloride is 58 grams per mole. So I would basically say, okay, 58 grams, and then I would add enough water to have a 1 liter total, and that would be a 1 molar solution of sodium chloride. So that's something to keep in mind when you're doing these problems. It kind of helps you check your answers and so forth. Let's take a look at a couple of these here. We have, on this first one here, 2.5 grams of sodium chloride, but we want a total volume of 125 milliliters. And they're asking you, okay, what's the molarity? Okay, so let's see here. We'd say, all right, I got 2.5 grams for a total volume of 125 milliliters. All right. Now, we need to get this in the moles here because we're obviously dealing with molarity. So, sodium chloride, you're going to work with this so much you'll just remember it's 58 grams per mole. So I need to say, all right, I've got 58 grams of sodium chloride for every 1 mole of sodium chloride. And this is 2.5 grams of sodium chloride. Okay, now, we need to be in liters here. So we're going to say, let's see, 1,000 milliliters in 1 liter. So I've got my molar mass factor, my milliliters to liter factor, and then this is how much grams of sodium chloride in my total volume here. So if I multiply that out, I should be able to, let's see, get my moles per total volume in liters here. Let's take a look at that. So we have 2.5 divided by 58 times 1,000. I don't like that. Let's do it again. 2.5 divided by 125 divided by 58 times 1,000. And that's going to give me a molarity of, I got 2 sig figs in my original measurement there. So I'm going to go 2 here. How about 0.34 molarity? 0.34 molarity. Hopefully that's what you got. You got an answer key or so forth. All right, how about this next one here? We got 68.4 grams of sodium phosphate, and we want a total volume of 378. What is the molarity? All right, much the same way. 68.4 grams of sodium phosphate. Now that would be a total volume of 378 milliliters. All right, so the molar mass of sodium phosphate. You're dealing with 3 sodiums at 23 apiece. Phosphorus is about 31. And then you got 4 oxygens at 16 apiece. So you're talking 20, 40, you got 69 here. Phosphorus, like I said, is 31. And then I got 64 wrapped up in these oxygens. So my molar mass there is going to be 69 plus 31 plus 64 should be 164. Does that seem right there? 164. Let's see. This seems right. All right. So 164 grams of sodium phosphate for 1 mole of sodium phosphate. Okay, and then we need to say, well, look, my total volume is 378 milliliters, but I need to be in liters, so 1,000 milliliters in every 1 liter. All right, let's see what we get here. We're going to go 68.4 divided by 378 divided by 164 times 1,000. And we are dealing with a molarity of, I got 3 sig figs here, so I'm going to go 3 in my answer. Let's go 1.10 molar solution of sodium phosphate. All right. On this next one here, we actually are given the molarity, and this is my total volume, and they want to know, well, how do I make this? How many grams would I have to put in there? Okay, so let's say we got 0.218 moles of sodium hydroxide, and that's going to be in a total volume of 792 milliliters. And let's see, we need to figure out our grams here. So if we multiply this, we could say, okay, what's my molar mass of sodium hydroxide? Sodium's 23 plus 16, let's see, 30, 43, it'd be 39, it'd be 40. 40 grams in 1 mole. So 40 grams of sodium hydroxide in 1 mole of sodium hydroxide. Let's see. And then let's see here. Actually, that might be all I need to do on that one. Let's see. Yeah, I got moles. Let's see here. 1,000 milliliters in a liter. Let's see what I get on that. 0.218 divided by 792 times 40 times 1,000. Oh, something doesn't seem right with that. Let's try that again. 0.218, that's my moles, times 40. That would give me my grams. And then I got this factor of 1,000 to 792. So times 1,000 divided by 792. So there it is. How about that? Does 11.0 grams seem about right? Let's see. Grams of sodium hydroxide. That's a pretty low molarity. So that's what I'm going to go with. 11.0 grams. All right, and we got one more here. 2.6 liters of a 0.185 molar solution of potassium. Is that potassium permanganate, I believe? And they want to know how many grams do we need. Okay, so I would say, all right, 0.185 moles of potassium permanganate. And this is probably how I'd probably say, okay, that's per a liter. If I have that molar solution, it's per 1 liter. And I'm going to scale this up here in a second. Now, what is my molar mass of potassium permanganate? Potassium's 39, and I have a manganese, which is 55, and then I got 4 oxygens at 16 apiece, so 64 plus 55 plus 39. And we're dealing with a molar mass of about 158. So 1 mole of this potassium permanganate is 158 grams of KMnO4. 1 mole KMnO4. Now, we don't just want to make a liter, we want to make 2.6 liters. So I would need a factor of, I need to multiply that by 2.6. So 2.6 liters is my ultimate goal there. So let's see here. I'm going to have, okay, so liters, moles. My grams should come out right. Let's see what I get there. 0.185 times 158 times 2.6. And are we dealing with about 76.0 grams of KMnO4, potassium permanganate, I believe. And so I think that was one of your choices on that one, about 76. Real quick, going back to this previous problem, I felt like I got hung up on a little bit here. What was I looking for? The grams. Yeah, I think I'm good. 11 grams looks good. All right. Cheers, boss.